Okay, let's talk a little bit about what I used to have out in the Aquaponics system. So I have a bunch of different devices that I had hooked up, and I want to just quickly go over them because they mean something in as much as much of that same functionality I want to have available, but in a different form once I reconstitute all of this using the things board. So let's start from the end. I used the ESP8266 main board, the micro control unit. And I sort of feel that, Dr. Frankenstein would no doubt have been proud if he'd seen this. This was just sort of super hacked together, and everything worked. And I was putting this away in a box so no one actually saw it. Everything worked. I didn't care. That was fine. It's easy to get to. Mount everything using this sort of thin plastic. I'll just zip tie things on. There is a Velcro piece on the back side that would just stick into my electronics box outside. It wouldn't hit the floor if it got wet or anything like that. It would just stay up on the side. If I needed to bring it inside to work on it, off comes the Velcro. I could just bring it in and work. Easy peasy. It has its own little power supply. All we need is about 5 volts to drive the board. It has a humidity and temperature measurement. It has 2 relays. And then it would control the pump for a soil-based watering system. It would control a feeder for the fish. It would control LED lights within the fish tank. And it will have a separate heavy-duty 12-volt power supply to do all of this without having to try and draw too much power from this one. The fish feeder was essentially just a small geared motor. That motor would drive a massive drill, and there would be a sort of conical shape down where the fish food would drop into this, and then once a day it would turn and push the fish food out of the end of the PVC pipe this was mounted in. Unfortunately, there were some issues with this. It was outside, moist got into the system, and the electronics didn't fail, but the fish feed actually stopped the system moving. What I need to do is do some sort of better housing so the fish food is not sucking up moist. So this is the main board. This is what really needs to be redone, and that's part of this here cleanup project. So let's put that to the side for a second. I also had a mechanical. I bought like an old, it's not old, but I bought a very, very cheap, it's about $12 I think, mechanical valve for the water faucet outside. And I sort of hacked it. I took away the LCD controls that are on here. Basically it was meant as a timed irrigation system. I took that off, made a manual controls to the motor inside. That goes out. That means I can plug this into a normal water faucet outside. And that's well kept. Here we go. That's to the side. And I have a control wire going out. This goes out to this here nifty thingy. Everything is bought at all these containers are from the dollar store. In here I have another ESP8266 microcontroller, and a small voltage regulator, and a motor control unit. And I have a small script that basically turns the motor to one side or the other for a second, and that opens or shuts the valve. It then double checks what's the position before it does the opposite when trying to close. At the bottom we have an ultrasonic measuring device, as well as a humidity and temperature gauge. So the speed of sound is dependent on the temperature and the humidity in the atmosphere at the time. So what this will do is it will do ongoing measurements of the humidity and the temperature, and with those measurements it will calculate the speed of sound for that particular environment. It does this some 100 times a day or so. And then the ultrasonic device essentially will sit, if you imagine this from the side, this will be it will sit inside a big PVC pipe within the water reservoir. When the water reservoir fills up to a certain point, okay, I don't need to do anything. It then knows that if it's, let's say, more than 15 centimeters, If it's more than that, then I know that the water level is too low, and this needs to turn on the valve and do a little bit of top up from the water faucet outside. When it knows that there's enough in the system again, the valve will shut off again, and it will just do these tests I think it's set to do a check every 15 minutes or so. And again, it doesn't matter, it could do this like many times in an hour. It's not an issue. It's just a separate autonomous device outside. So this particular ultrasonic device has a bit of a bad reputation for being for dishing out some weird data once in a while. So it will do like 10 measurements, and then once in a while there will be one that says, oh, actually it's 15 meters away. So you gotta find a way to work around the crazy data that some of these measurement devices come out with once in a while. The way I got around it was I said, well, okay, well, let's do 10 measurements once every second, and then we'll do an average, and everything that is above 30 centimeters or below 2 centimeters, we'll ignore that data. So I only have data that I know that is within the range of the actual tank, and I'll do 10 measurements, and I'll do the average of that. That gets validated. Is it above or below the 15 centimeters? And according to that, it will turn the valve on or off. So that's a bit of a short look at some of the devices that was present outside. Now all of this is a bit of a mess, and I've been wanting to redo this Frankenstein monster for a long time. So all of this is pretty much functionality that I want in the system again, but I want not to have this particular unit provide a very simple web interface, and again I'll show you this in a second. I want a localized, Docker contained things board UI. Essentially, it's a central web interface that has authentication against each of the devices, and all the devices needs to do is send data and receive instructions on whether or not they need to perform an action or not. Turn on a relay, turn on the valve, anything like that. Turn on the fish feeder, the LED lights in the fish tank, that sort of thing. And once we get that, all that data comes into the central location. We can do all sorts of analysis on it, and that's really what I need to do. And depending on the analysis, we can then send an action back, or we can do warnings if the higher temperature, low water. We can start measuring the water over time and get graphs and see, okay, well, when in the year am I losing the most water? Why am I losing it? Is it going to the plants due to low humidity in the soil and I'm doing automatic watering? Is it going for surface evaporation? All that sort of thing is stuff that I would like to try and see if I can cover in this one interface. So yeah, come along. I'm not saying that I can actually do all of this. I'm saying I want to do some of this. And yeah, come along with me, and let's see if we can make all of this work. Cheers.